So in this video, we're going to talk about how to solve 3 by 3 systems using Desmos to perform Gauss-Jordan elimination. So what we're going to be doing is we're going to be taking our augmented matrix and transforming it into reduced row echelon form, which is abbreviated rref. Notice that this is different than the row echelon form that we were talking about in the previous lesson. So here's an example of a matrix in reduced row echelon form. Notice that the first three columns are the identity matrix. So that's why we have all these ones on the diagonal, and then every other entry in this matrix is a zero. So what is the advantage of reduced row echelon form? Well, it actually tells us the solutions to a system. So suppose we had a matrix like this in reduced row echelon form where A, B, and C were constants. If we write the equations that are represented by this matrix, notice that this is telling us that x equals A, y equals b, and z equals c. So you can see here, we can tell that the solution to this system is going to be the ordered triple A, B, C. So in this example here, you could say that the solution to this system of equations is going to be 7, 5, 3. So you may be wondering, how do we do this? How do we go about taking an augmented matrix and transforming it into reduced row echelon form? And as an example for you, I went ahead and took this augmented matrix and transformed it into reduced row echelon form, and I wrote out all my steps. So we won't actually be doing these by hand in this class, but if you're curious about how it works, you can see that all I've done is taken all the row operations that you're already familiar with and combined them to work on getting this matrix into reduced row echelon form. And really, if you think about it, it's kind of like solving a puzzle, right? But like I said, we're not going to be doing that in this class. So we are actually going to use our graphing calculator to help us out. So in this video, I'm going to go over how to do this in Desmos. And what we have here is a reduced row echelon form function that will take an augmented matrix that we enter and convert it to reduced row echelon form. So let's learn now how to do this in Desmos. So you're going to need to go to desmos.com, and then from up here in Math Tools, we're going to open up the matrix calculator. So when we open up the matrix calculator, we're going to click New Matrix, and then we're going to tell it to make matrix a 3 by 4 matrix. And we're just going to go ahead and enter these values now. So we have 2, 1, -4, 7, 2, 4, 2, 40, 6, -2, 4, and 44. Okay, so now that we have these values entered, we're going to click the blue enter. It's like the arrow button means enter. And so we're going to tell it now to find reduced row echelon form. So we click this RREF in the bottom left corner, and then we're going to click A to tell it to calculate reduced row echelon form of matrix A. So you can see now it's calculated reduced row echelon form, and you can see that the last column tells me the values of X, Y, and Z. So we know that the solution to the system is going to be 753. Here's our problem solving strategy. So we're going to solve 3 by 3 systems by setting up an augmented matrix that our calculator will then convert to reduced row echelon form. So our steps are going to be to first make sure that all our equations are in standard form. Then we're going to set up an augmented matrix A and note its dimensions. We'll then enter matrix A into the calculator and then click reduced row echelon form and then click A to find the reduced row echelon form of A. The last column of the matrix in reduced row echelon form will give us the solutions to the system of equations. Then we'll write our solution as an ordered triple, which is x, y, z. So let's go ahead and practice now with some examples. So you notice that all these equations are already in standard form. So we're going to go ahead and set up our augmented matrix A. So matrix A, and when I set up the augmented matrix, I want to go ahead and add in those coefficients of 1 that are implied in my equations, because that just helps me keep track of these. So I'm going to write the first row, which is 1, 2, 1, and then 9. And then the second row is going to be 2, 1, 3, 0. And then the third row is going to be 3, -4, -5, and 1. So now let's go to Desmos and go ahead and enter this matrix. So I'm just going to click clear. And then when I click clear all, it just completely erases everything. So I now type new matrix, and then I'm going to say 3 rows and then 4 columns. And now let's go ahead and enter these values. So we have 1, 2, 1, 9, 2, 1, 3, 0, and then 3, -4, -5, and 1. Okay, so now that we have matrix A, we're going to go ahead and click enter. And then we're going to click rref, and then we're going to click A, and it gives us the reduced row echelon form of A. So we know that the solution to this system of equations is going to be 2, 5, -3. Okay, so now let's try this example. So once again, we have a system of equations that are all in standard form. So we're going to practice writing out the augmented matrix. So my coefficients of 1, I'm going to go ahead and add in. So we have 2, 1, 1, 1. And then we have 3, 2, 3, 12. And the final row is going to be 4, 1, 2, -1. Okay, so now let's go back to Desmos. I'm going to clear everything. And now I click new matrix. Matrix A has 3 rows, 4 columns. So now I just type in my values. So I have 2, 1, 1, 1, 3, 2, 3, 12, 4, 1, 2, and then -1. Okay, so now hit enter. And then we're going to do rref, and then we do matrix A. And it now gives us the solutions in reduced row echelon form. So the solutions will be -4, 3, and 6. So remember, sometimes we encounter systems that have no solution or infinite solutions when we're solving 3 by 3 systems. So what does this look like when we're solving using reduced row echelon form? Well, when you find your answer, you're going to see something unusual in the last row of the matrix. So for example, you can see in this matrix here, I have my last row is all zeros. So this is like the situation where we have 0 equals 0. And remember, we said that's infinite solutions, right? Because 0 equals 0 is always true. So this is an example of a system that'll have infinite solutions. The last row will be all zeros. If we have no solution, the last row will look like this. You'll have all zeros and then followed by a 1. So if you think about this, this is basically like saying 0 equals 1, which doesn't make any sense. So that's why the system will have no solutions. So let's look at this example. Let's try solving this system. So remember, to solve, I'm going to start off by setting up the augmented matrix. So I'm going to add in this coefficient of 1 here. So my augmented matrix is going to look like this. I have -4, -2, -1, and then 15. And in row 2, I have 12, 6, 3, and -45. And in row 3, I have 2, 5, 7, and -29. So now let's go to Desmos and enter this in our calculator. So we have new matrix, 3 rows, 4 columns, and let's type in our values now. So we have -4, -2, -1, and 15, and then 12, 6, 3, -45, and 2, 5, 7, and -29. Okay, so now I'm going to hit enter, and then I'm going to click rref and then choose matrix A. And you can see here it gives me that strange case in my last row, right? I have a row full of zeros. So this is telling me that 0 equals 0, which means that this system of equations will have infinite solutions. Now let's try this example. Let's try solving the system. So to do this, I'm going to start off by setting up the augmented matrix. So I have -6, -9, -12, and then 21. And then I have -2, 3, -4, and 7. And then 10, -15, 20, and -30. Okay, so now let's go to our calculator. And so we do new matrix and then 3 rows, 4 columns. And let's type in these values now. So -9, -12, 21, -2, 3, -4, and 7. And then 10, -15, 20, and -30. Okay, so we click enter, and then you click rref and then choose A. And you can see here, look at the last row, it's all zeros and then 1, right? So that's telling me like 0 equals 1. So that means that this system will have no solution. All right, so now you've learned all three methods of how to solve 3 by 3 systems. Remember, you can solve these systems algebraically using matrices with Cramer's rule, by Gaussian elimination, or you can take it a step further and do Gauss-Jordan on the calculator. So remember, we can use an augmented matrix to help us solve a 3 by 3 system of linear equations. Using our calculator, we can transform an augmented matrix to reduce row echelon form, which will tell us the solutions to the system.